Holmium is a chemical element with symbol Ho and atomic number 67. Part of the lanthanide series. Holmium is a rare earth element. Holmium was discovered by Swedish chemist Per Theodor Cleve.Its oxide was first isolated from rare earth ores in 1878 and the element was named after the city of Stockholm. Elemental holmium is a relatively soft and malleable silvery white metal. It is too reactive to be found uncombined in nature, but when isolated, is relatively stable in dry air at room temperature. However, it reacts with water and rusts readily, and will also burn in air when heated. Holmium is found in the minerals monazite and gadolinite, and is usually commercially extracted from monazite using ion exchange techniques. Its compounds in nature, and in nearly all of its laboratory chemistry, are trivalently oxidized, containing Ho ions. Trivalent holmium ions have fluorescent properties similar to many other rare earth ions, and holmium ions are thus used in the same way as some other rare earths in certain laser and glass colorant applications. Holmium has the highest magnetic permeability of any element and therefore is used for the pole pieces of the strongest static magnets. Because holmium strongly absorbs neutrons, it is also used as a burnable poison in nuclear reactors. Characteristics. Physical properties. Holmium is a relatively soft and malleable element that is fairly corrosion resistant and stable in dry air at standard temperature and pressure. In moist air and at higher temperatures, however, it quickly oxidizes, forming a yellowish oxide. In pure form, holmium possesses a metallic, bright silvery luster. Holmium oxide has some fairly dramatic color changes depending on the lighting conditions. In daylight, it is a tannish yellow color. Under trichromatic light, it is a fiery orange-red, almost indistinguishable from the appearance of erbium oxide under the same lighting conditions. The perceived color change is related to the sharp absorption bands of holmium interacting with a subset of the sharp emission bands of the trivalent ions of europium and terbium, acting as phosphors. Holmium has the highest magnetic moment, 7 quintillion 1 quadrillion 106 trillion spade suit 10.6 micro b of any naturally occurring element and possesses other unusual magnetic properties. When combined with yttrium, it forms highly magnetic compounds. Holmium is paramagnetic at ambient conditions, but is ferromagnetic at temperatures below 7 quintillion 1 quadrillion 190 trillion spade suit 19K. Chemical properties. Holmium metal tarnishes slowly in air and burns readily to form holmium oxide. 4Ho plus 3O2 2Ho 2O3. Holmium is quite electropositive and is generally trivalent. It reacts slowly with cold water and quite quickly with hot water to form holmium hydroxide. 2Ho plus 6H2O2 Ho 3 plus 3H2. Holmium metal reacts with all the halogens. 2Ho plus 3Fu 2 Hof 3 2Ho plus 3Cl2 2HOCl3 2Ho plus 3Br2 2HOBr3 2Ho plus 3I2 2Hoi 3. Holmium dissolves readily in dilute sulfuric acid to form solutions containing the yellow Ho ions, which exist as a 3+ complexes. 2Ho plus 3H2SO4 2Ho 3 plus 3SO2 minus 4 plus 3H2. Holmium's most common oxidation state is +3. Holmium in solution is in the form of Ho3+, surrounded by 9 molecules of water. Holmium dissolves in acids. Isotopes. Natural holmium contains one stable isotope, holmium 165. Some synthetic radioactive isotopes are known. The most stable one is Holmium-163, with a half-life of 4,570 years. All other radioisotopes have ground-state half-lives not greater than 1.117 days, and most have half-lives under 3 hours. However, the metastable 166m1 has a half-life of around 1,200 years because of its high spin. This fact, combined with a high excitation energy resulting in a particularly rich spectrum of decay gamma rays produced when the metastable state excites, makes this isotope useful in nuclear physics experiments as a means for calibrating energy responses and intrinsic efficiencies of gamma-ray spectrometers. History. Holmium was discovered by Marc Delafontaine and Jacques-Louis Sauret in 1878, who noticed the aberrant spectrographic absorption bands of the then unknown element. Later in 1878, Per Theodor Cleve independently discovered the element while he was working on Erbia Earth. Using the method developed by Carl Gustav Mosander, Cleve first removed all of the known contaminants from Erbia. The result of that effort was 2 new materials, one brown and one green. He named the brown substance Holmia and the green one Thulia. Holmia was later found to be the Holmium oxide and Thulia was thulium oxide. In Henry Moseley's classic paper on atomic numbers, Holmium was assigned an atomic number of 66. Evidently, the holmium preparation he had been given to investigate had been grossly impure, dominated by neighboring dysprosium. He would have seen X-ray emission lines for both elements but assumed that the dominant ones belonged to holmium, instead of the dysprosium impurity. Occurrence and production. Like all other rare earths, holmium is not naturally found as a free element. It does occur combined with other elements in gadolinite, monazite, and other rare earth minerals. The main mining areas are China, United States, Brazil, India, Sri Lanka, and Australia, with reserves of holmium estimated as 400,000 tons. Holmium makes up 1.4 parts per million of the Earth's crust by weight. This makes it the 56th most abundant element in the Earth's crust. Holmium makes up 1 part per million of the soils, 400 parts per quadrillion of seawater, and almost none of Earth's atmosphere. Holmium is rare for a lanthanide. It makes up 500 parts per trillion of the universe by weight. It is commercially extracted via ion exchange from monazite sand but is still difficult to separate from other rare earths. The element has been isolated through the reduction of its anhydrous chloride fluoride with metallic calcium. Its estimated abundance in the Earth's crust is 1.3 mg per kilogram. Holmium obeys the Otto-Harkins rule. As an odd-numbered element, it is less abundant than its immediate even-numbered neighbors, dysprosium and erbium. However, it is the most abundant of the odd-numbered heavy lanthanides. The principal current source is some of the ion-adsorption clays of southern China. Some of these have a rare earth composition similar to that found in xenotime gadolinite. Yttrium makes up about 2/3 of the total by weight. Holmium is around 1.5%. The original ores themselves are very lean, maybe only 0.1% total lanthanide, but are easily extracted. Holmium is relatively inexpensive for a rare earth metal, with the price about $1,000 per kilogram. Applications. Holmium has the highest magnetic strength of any element, and therefore is used to create the strongest artificially generated magnetic fields. When placed within high-strength magnets as a magnetic pole piece, since it can absorb nuclear fission-bred neutrons, it is also used as a burnable poison to regulate nuclear reactors. Holmium is used in yttrium iron garnet and yttrium lanthanum fluoride solid-state lasers found in microwave equipment. Holmium lasers emit at 2.1 micrometers. They are used in medical, dental, and fiber optical applications. Holmium is one of the colorants used for cubic zirconia and glass, providing yellow or red coloring. Glass containing holmium oxide and holmium oxide solutions have sharp optical absorption peaks in the spectral range 200 to 900 nanometers. They are therefore used as a calibration standard for optical spectrophotometers, and are available commercially. The radioactive but long-lived Ho-166M1 is used in calibration of gamma-ray spectrometers. Biological role. Holmium plays no biological role in humans, but its salts are able to stimulate metabolism. Humans typically consume about 1 milligram of holmium a year. Plants do not readily take up holmium from the soil. Some vegetables have had the holmium content measured, and it amounted to 100 parts per trillion. Toxicity. Large amounts of holmium salts can cause severe damage if inhaled, consumed orally, or injected. The biological effects of holmium over a long period of time are not known. Holmium has a low level of acute toxicity.